In this session, we're going to configure ToolShop for a machine. This step is very important because the software needs to know what tooling is available before you can create a job. When you start ToolShop, it will ask you to select the material to work with. Just click OK for now, and we'll get back to this a little later. The next thing we need to do is click on the Options menu and then click Select Machine. If you have a fresh installation, you will not see any installed machines. You need to click Import, then navigate to the folder where you install the software from. This is most likely in your Downloads folder. There you'll find a folder called Drivers. You can choose from any of the ones supplied. These files are actually a collection of tooling that matches your type of machine. That's why many of the supplied files actually describe the cutting device, such as a router or various hypertherm plasma units. For this demo, we will choose the router option. Clicking OK will import the machine configuration along with the default tooling. Now you have the option to choose the post-processor to match your machine. This is the language converter that correctly formats the G-code that goes to your CNC machine. Click the Select button beside the post-processor and you will be able to choose from several post-processors. If you have specific post-processor requirements, please contact your ToolShop distributor for assistance. For now, we're going to choose the ART post-processor. Once we have selected the machine, the next step is to set up the tool changer. Because I imported a router machine in the Select Machine dialog that has bought in a set of tools which match a CNC router. These generally include drills and router bits. Here you can see that we have a selection of default tooling. These are metric, but you can call them anything you like. We're going to add a new router bit to the machine, and we'll do that simply by clicking on the Add button here. I'm going to give a name. In this case, I'm going to call it a 1/2-inch router. When I click OK, it asks me to choose from the basic style of cutter that I'm setting up. In this case, I'm going to choose router. The different types actually give different capabilities and control what can and can't be done with this tool. A router bit will be able to do all of your general offset cutting, along with rebates, fills, and drilling. As you can see, it has been added to the list of tools, and that's pretty much it. You also have the option to set up specific templates for this tool. As you get familiar with ToolShop, you'll realize that it is very template-driven. So the idea for this is to set up the basic parameters for the tool, which will be used as default for the very first time you use it. It's not super important to create a template just yet, but just for the exercise, we'll go through it with you. First of all, I'm going to create a new template for this 1/2-inch router by clicking the New Template button here. I'm going to create an offset routing template, although you have several options. Fills, diamond cutting, marking, drilling, and offset cutting. These are types of machining that are applicable to the type of tool you specified earlier. Offset tool paths are the regular type of tool path that you use for cutting outside or inside of shapes. I'm not going to restrict this template to any particular material, although I could if I chose. For the time being, I'm just going to leave this as a default template for this tool. Notice that I could set up a specific tool for a specific material and even a specific thickness, and the tool template will only be available for materials that match those specific parameters. You can also give the template a meaningful name. You could, for instance, say this is the 1/2-inch router bit /6mm acrylic /cut through, or something like that. Here we have the basic parameters for this toolpath template. Because my current configuration is in metric, I'm going to set the cut width, or tool diameter, as 12.7 millimeters. If your configuration is in metric, you would enter 0.5 for 1/2 inch. Notice that we have several options with depth control. It's not simply from a surface. You can choose the reference point that you're measuring from. Now, this is an important point because you can set up a template that will manage multiple material thicknesses and will automatically adjust the depth, the number of passes, and things like this to suit the material thickness. In this case, I'm going to choose below the bottom, and I'm going to choose to go 0.5 of a millimeter below the bottom of the material. Because I'm using the bottom of the material as the reference, this will adjust the cut depth according to the thickness of each material. I'm going to give it a default feed rate of 3000, which is 3000 millimeters per minute. If you're configured in inches, you would enter something around 120 inches per minute. I'll set the default plunging speed at 1500 millimeters per m. We've got the spindle speed, which I'm going to run at 20,000 revolutions per minute, and we've got other parameters which you can generally ignore for routers. For instance, we have overcut and undercut, which allows you to get it to cut just a little bit past the start point each time if you want a little overlap. If this tool doesn't plunge very well, you can choose to have a ramp lead in, so it will start at the surface and ramp down. There's conventional and climb direction, which will change the direction of the cut. Sharp corners affect the way the machine behaves when it goes past a sharp corner, and generally you want it set to sharp corners. There's some other parameters here which we can get into at a later date, mostly maximum limits and things like that. The next section here is Open Toolpath. You can choose whether you want to ignore single lines in your file that aren't part of a closed shape, and you can turn this on or off. I'm going to turn this off for now. The next section, lead-ins and lead-outs as well. This is entirely customizable for you. Say you would like a 5mm lead-in and you would like it to follow the side. I don't really want it to have a lead-in that sticks out from the shape a whole lot, so I'm just going to come in at 5 degrees and I'm not going to bother with the lead-out. I'm also going to set the maximum depth per pass of this tool. Because it's a 1/2 inch diameter, I know it can easily go 1/2 inch deep per pass, probably a lot more. But in this case, I'll put 12.7mm or 1/2 inch as the limit per pass. I'm not going to use the cleanup function. I'm just going to let the tool finish on the first cut. Starting depth can be used later for if you want to start in the bottom of an existing pocket to save time. There's also some other controls for bridges, inlays, and various things like that. But remember, this is just the default template that we're setting up. That tool is now available. You can see here in the tool list that we have the 1/2 inch router bit with an offset template, and it's available for all materials, and it's got those default parameters which will make it cut in a certain way. The next thing we need to do is set up our tool changer. Because we have a blank machine, we need to add tool positions from scratch. Clicking the Add button allows you to enter the tool position numbers. Here I'm going to start with the very first tool. So I'll enter 1 and click OK. That then allows me to assign a tool to that tool position. So in this case, I'm going to set up a 3mm drill. Next, I'm going to set up 4mm drill, maybe a 5mm drill, and a 6mm drill. So that's pretty good for cabinet making and things like that. I'm going to go further and start adding my router bits. I'm going to go with a 3mm router bit in position 5. Then we have 6mm router bit in tool position 6. I'm going to assign an 8mm router a bit to position 7. I'll put the 1/2 inch router bit in position 8, and I'm going to put a 90 degrees V cutter in position 9. A lot of CNC routers have 10 tools in the carousel. Maybe you've got more or less. Perhaps you got a tool holder for a pen. So let's put a marker pen in number 10. So now we have a fully assigned tool changer setup. This will now allow us to create CNC jobs using all of those tools.